Hello everyone, I'm Kamran Nisa and I'm going to explain about 3D printing. 3D printing is also known as additive manufacturing. 3D printing or additive manufacturing is process of making three-dimensional solid objects from a digital file. The creation of a 3D printed object is achieved using additive process. In an additive process, an object is created by laying down successive layers of material until the entire object is created. Each of these layers can be seen as a thinly sliced horizontal cross-section of eventual object. The objects can be of almost any shape, size, and geometry, produced from a 3D model or other electronic data source. 3D printer is a type of industrial robot. This is a sample 3D printer. In 1984, Chuck Hull of 3D System Corporation invented a process, stereolithography, which is the layers are added by curing polymer, photopolymers, and UV lasers. Hull defined this as a system for generating 3D objects by creating cross-sectional pattern of objects to be formed. He also developed stereolithography file format widely accepted by 3D printing software, as well as digital slicing and infill strategies that are common to many processors today. The term 3D printing originally referred to a process employing standard and custom inkjet print heads. The technology used by most 3D printers to date is fused disposition modeling. By early 2010s, the term 3D printing and additive manufacturing developed senses in which they were synonymous umbrella terms for all eight technologies. The 2010s were the first decade in which metal parts such as inkjet brackets and large nuts would be grown in job production rather than obligately being machined from bar stock or plate. Term subtractive does not replace term machining, instead complementing it when a term that covers any removal method is needed. Wire, which is unwound from a coil and supplies material to an extrusion nozzle which can turn the flow on and off. The nozzle is heated to melt the material and can be moved in both horizontal and vertical directions by a numerically controlled mechanism, directly controlled by a computer-aided manufacturing software package. The object is produced by extruding melted material to form layers as the material hardens and immediately after extrusion from the nozzle. The term fused disposition modeling and its abbreviation to FDM are trademarked by Stratasys Inc. The exactly equivalent term fused filament fabrication was coined by the members of RepRap project to give a phrase that would be legally unconstrained to in use. The basic principles of 3D modeling are printing, modeling, and finishing. Coming to modeling, 3D printable models may be created with a computer-aided design or package via 3D scanner. Manual modeling process of preparing geometric data for 3D components graphics is similar to plastic art such as sculpting. 3D scanning is process of analyzing and collecting digital data on shape and appearance of real objects. Based on this, 3D models object can be produced. Coming to the printing, before printing 3D model from an STL file, it must first be processed by a piece of software called Slicer, which converts the model into a series of thin layers and produces a G code for file containing instructions tailored to specific printer. 3D printer follows G code instructions to lay down successive layers of liquid, powder, paper or sheet material to build the model from series of cross sections. These layers are joined automatically to create final shapes. Construction of model with contemporary methods can take anywhere from several hours to days depending on method and size of the model. Traditional techniques like injection molding can be less expensive for many applications, printing a slightly oversized version of the desired objects and standard resolution and removing material with higher resolution subtractive process can achieve greater precision. Some additive manufacturing techniques are capable for using multiple materials in the course of constructing parts. Coming to the finishing, though the printer produced resolution is sufficient for many applications, printing a slightly oversized version of the desired object in standard resolution and then removing material with a higher resolution subtractive process can achieve greater precision. Some additive manufacturing techniques are capable of using materials in the course of constructing parts. Some are able to print in multiple colors and color combinations simultaneously. Some also utilize supports when building. Supports are removable or dissolvable upon completion of the print and are used to support overhanging features during construction. 3D printing process. A large number of additive processes are now available. The main difference between processes are in the way layers are deposited to create parts and in the materials that are used. Some methods melt or soften material to produce the layers, example selective laser melting or direct metal laser sintering, while others cure liquid materials using different sophisticated technologies, example stereolithography. Thin layers are cut to shape and joined together. Each method has its own advantages and drawbacks, which is why some companies consequently offer a choice between powder and polymer for material used to build the object. The 3D printing process, in short, can be seen as a laser source sending a laser beam to solidify the material, then an elevator raising or lowering platform to help lay the layers, and a vat containing the material used to create the 3D object. The 3D object is created as part are layered on the top of each other. Advanced 3D printers use one or more materials including plastic, resin, titanium, polymers, and even gold and silver. The flow of events can be seen as input model is given to the structural load generator, which in turn gives it to the structural analysis, where all the analysis is taken place, all about hollowing, thickening, correction, evaluation, etc. And finally, the output is produced. 3D printing is basically all about building up the layers. Four types of 3D printing are inkjet 3D printing, fused disposition modeling, stereolithography, selective laser sintering. Personal 3D printing or domestic 3D printing is mainly for Personal 3D printing or domestic 3D printing is mainly for hobbyists and enthusiasts and really started growing in 2011. Because of rapid development within this new market, printers are getting cheaper and cheaper. The RepRap open source project really ignited the hobbyist market. For about $1,000, people have been able to buy the RepRap kit and put together their own personal 3D printer, complete with any customization they were capable of making. This rapid development of open source 3D printers is gaining interest in both the developed as well as the developing world and is enabling the hyper customization and all the use of design in public domain to fabricate open source appropriate technology through conduits such as Thingiverse and Qubify. This technology can also assist in sustainable development such as technologies are easily and economically made from readily available resources by local communities to meet their needs. 3D bioprinting, by definition, is the system of delivering 3D structures and geometrics utilizing cells and representation material. The remedial application of 3D bioprinting are different and are in this way the subject of genuine examination of insightful associations. One noteworthy application area of bioprinting is in the tissue building field of regenerative arrangement. Despite the complexities associated with 3D printing all around, extra considerations must be taken concerning material, cell sort, and advancement variable choice. Because of these extra thoughts, bioprinting examination is truly a cross-disciplinary take a stab at including investigators from the fields of material science, cell science, planning of various sorts and medication. 3D bioprinting has seen much preparatory achievement to the extent that the time of a couple of different sorts of tissues. These fuse skin, bone, cartilage, trachea, and heart tissues. While preparatory accomplishment has been accomplished in these non-critical utilitarian tissue structures, critical examination effort is guided towards the period of totally helpful substitution organs and tissues, for instance, aortic heart valves. Research This is a 3D bioprinted cartilage which looks almost similar to the real one. Working of basic 3D bioprinter can be seen as it is controlled by a custom controller wherein a fiber optics gets in, which is controlled by the high voltage power supply, then into the electrostatic print head, then falls onto the printed layer, onto the electrospun layer. 3D printing system can be used to create nanoscale things. Such printed articles are frequently gotten to be a solid substrate, example silicon wafer, to which they follow in wake of printing as there are exorbitantly little and fragile to be controlled post-advancement, while 2D nanostructures are ordinarily made by keeping materials through a static stencil over. 3D nanostructures can be printed by physically moving a stencil shroud in the midst of material formation process. Programmable tallness nanostructures, which are meager, have been made by metallic physical vapor explanation through a piezoactuator controlled stencil cover having a handle nanopore in a silicon nitride layer. This metal vapor technique is moreover advantageous because it can be used on surfaces that are so sticky, so tricky it would be unthinkable high temperature chemicals for ordinary lithography to be used on. This is a car which is printed using a 3D printer. It is named as Ruby. 3D printing process allow for mass customization, the ability to personalize products according to individual needs and requirements. Even within the same build chamber, the nature of 3D printing means that numerous products can be manufactured at the same time according to the end user's requirement at no additional process cost. Finally, 3D printing can be seen as a dream. It is a fantasy that has now become reality. Thank you.